Hey everybody, Mr. Moreno here. I'm excited to try out my new camcorder. Decided instead of using a document camera because it's just way too choppy, I'm actually using my own personal camcorder. So if there's a few glitches here, I apologize, but other than that, I think we should be good to go. So let's make sure that we write our names at the top of our paper. And today's date, of course, which was 11/13/2015, and then your advisory. All right, so today we're going to be looking at adding and subtracting unlike fractions. So what we did last time, we were doing adding and subtracting like fractions. So if we have common denominators, we add or subtract the numerators. But this time though, we don't have common denominators. In fact, we have unlike fractions. So our objective today is to be able to add and subtract fractions with unlike denominators. So let's highlight add and subtract fractions with unlike denominators. What does unlike mean? Well, unlike just means different. So for example, last time we talked about having denominators that were the same. Just like these guys right here. Right? We got two bears here, they look almost identical. Let me zoom out a little bit. All right, there we go. So we had two bears right here, they're identical. These guys are common denominators, so they both look the same, right? But then one of them gets switched out with a denominator that looks different, right? You guys might remember him from the class. This is the loaf. This is Barry on the right-hand side. These guys are both uncommon denominators. So we want to get rid of the loaf and to have common denominators. Okay, that's our goal. Okay. I know it's a little silly, but hey, if it gets the point across, it's all good. So going back to the essential question, at the end of the lesson, you should be able to answer the following question. How does adding unlike fractions compare to adding like fractions? So let's highlight this. So there's a similarity, okay? So what we covered a few days ago is not completely different than what we've been doing, what we're gonna do today. So to add or subtract unlike fractions, that is the goal of today. To add or subtract fractions with different denominators. So in other words, denominators that are not the same. We need to follow a total of 3 steps. The first step, number 1, is to rename the fractions using the least common denominator. Otherwise known as the LCD. So we're going to rename the fractions using the least common denominator, otherwise known as the LCD. That's step number 1. Step number 2, we're going to add or subtract as with like fractions. So we're then going to add or subtract as with like fractions. And number 3, this is only if necessary. If necessary, simplify the sum or difference. Simplify the sum or difference. So looking at these 3 steps, and anytime we have different denominators, we need to do the following 3. If we don't do step 1, we can't do 2, and if we don't do 2, we cannot do 3. So we must follow these steps in the order that are given. The next part is before you can add 2 unlike fractions, or fractions with different denominators, you need to rename one or both of the fractions so that they have a common denominator. So just like these two guys right here, these guys are common. We want our denominators to look like them too, right? Identical, the same. When we have one that's different, okay, we got to get rid of one to make the other one look like the other denominator, okay? So that's our goal for today. All right, so let's do this one together. We want to find what 1/2 plus 1/4 is. Now, this is a little bit different than what we covered last time. Notice, we need to look at this and say, are the fractions like or unlike fractions? Explain. Well, I have a denominator of 2 and a denominator of 4 here, which means they are unlike because the denominators are different. They are unlike because the denominators are different. All right. The second thing we have to ask ourselves is, what do you need to do before you can add fractions with unlike denominators? So I can't just start adding 1 plus 1 because the denominators are not the same. If they were, I could do that, but because they're not, I have to do something. Therefore, I need to rewrite each of these fractions with using the LCD, or least common denominator. Okay, so rewrite each fraction using the LCD. So what I want to do for each of these problems that requires the use of an LCD, least common denominator, is that I know it might seem tedious, but we're going to find the common multiples of each of the denominators. So a common multiples of 2 include 2, 4, and we'll stop there. Multiples of 4 include, well, 4. Notice we have a common denominator of 4. Not only is it common, but it's also the least common denominator. So now that we've done that, we can then go ahead and multiply 1/2 times 2 to get 4. And then we'll multiply 1/4 times 1 to get 1/4. So we'll write this as 1/4. 1/2 times 2. Now I get that 2 by counting spaces. 1, 2. 2 times 1, we'll do that after. Plus 1/4 times 1 times 1. Now before we do any more math, let's look down here at the third question. Why does multiplying the numerator and denominator by the same number result in an equivalent fraction? Well, when you multiply the numerator and denominator by the same number, you are multiplying by 1. So let's write that down. When you multiply the numerator and the denominator by the same number, you are multiplying by 1. So let's go ahead and finish this problem. 1 times 2 gives me 2 over 2 times 2 gives me 4 plus 1 times 1 gives me 1, and then 4 times 1 gives me 4. Now I can do the same type of problem that I was doing a few days ago. I notice I have common denominators now, which means I can add the numerators. 2 plus 1 gives me 3 over 4. 3 over 4 is my final answer. It cannot be simplified any further. All right, at this point, what I want you guys to do is to pause the video and complete questions A, B, and questions C and D on the next page. When you're done with those 4 problems, please go back and pause or press play on the video and begin watching to see what my explanation is and how I solved each question. Now, I will tell you guys this. I know it might be tempting not to want to show your work, right? Oh, it's too much to write. I don't want to do it, blah, 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 right? If you skip any steps when you're doing these types of problems, you will mess up. I repeat, you will mess up. Especially once we get towards later on the notes, you realize there's a lot of work that needs to be shown. And if one step is skipped, it could really cause the problem to just go downhill quick. So at this point, please pause the video. If you get stuck, you may check your answer just to kind of prevent you from being stuck in one place for too long. If not, then I'll see you back in a few minutes. All right, so you should all have paused the video. We're going to go ahead and check our answers for each of the questions here. So let's first look at the first problem. A, it says 1/6 plus 2/3. So the first thing I notice is that I have different denominators, unlike denominators. So I'm going to go ahead and find the LCD of both 6 and 3 to find a common denominator. So the LCD of 6 would be 6, or a multiple of 6 would be 6. And some multiples of 3 include 3 and 6. Therefore, my LCD is 6. All right, now let's rewrite these fractions with my LCD. 1/6 times 1 times 1 plus 2/3 times 2 times 2. What you do to the bottom, you also do to the top, equals 1 times 1 is 1, 6 times 1 is 6, plus 2 times 2 is 4, 3 times 2 is 6. I now have common denominators, which means I can add the numerators together. 1 plus 4 gives me 5/6. My answer is simplified. Easy enough. Let's look at the next problem, letter B. 9/10 plus -1/2. I notice that I have two denominators that are different. Therefore, I have to find the LCD for the fractions. LCD, common multiple of 10, we'll just keep it as 10 for now. Some common multiples of 2 include 2, 4, 6, 8, and 10. Bingo, there's our common denominator. Now let's use that to rewrite our fraction. 9/10 times 1 times 1 plus -1/2 times 5 times 5. 9 times 1 gives me 9. 10 times 1 gives me 10. Plus -1 times 5 gives me 5. 2 times 5 gives me 10. All right, so remember all those problems we did yesterday where we were adding and subtracting integers? Well, the reason why we did all that is because we need to know how to add and subtract integers for these types of problems. So yes, I understand we are working with fractions, but because we have common denominators, we're only going to be adding and subtracting what's in the numerator. So this problem is really the same thing as saying 9 plus -5. According to integer addition rules, different signs we subtract. 9 minus 5 gives me 4. I take the sign of the number that is furthest away from 0. That gives me +9. So I have 4/10. But I want to simplify this in simplest form. So let me choose a number that can go into both 4 and 10. Let's try 2. So we're going to divide both the numerator and denominator by 2. 4 divided by 2 gives me 2. 10 divided by 2 gives me 5. And that's my final answer, 2/5. All right, so let's go ahead and turn the page. Let's do the next problem. Personally, I think letter C was probably easier than B. Should have put that one first, but anyways, it is what it is. All right, I look at my denominators and I notice that they are different. Let's find our LCD. LCD, common multiple of 4 includes 4, let's say 8. Common multiple of 8, well, let's just stop at 8. 8 and 8, boom, there's our LCD. All right, then we're going to go ahead and rewrite the fractions with our LCD. Oops, dropped my pen here. All right, we're going to write 1/4 times 2 times 2 plus 3/8 times 1 times 1. And I get 2/8 plus 3/8. I notice I have common denominators now, which means I can add the numerators together. 2 plus 3 gives me 5/8. 5/8 is as simplified as it can get. That's my final answer. And last but not least, letter D. We have -1/3 plus -1/4. Looks complicated, it's not. Let's write our LCDs. Some common multiples of 3 include 3, 6, 9, and 12. Common multiples of 4 include 4, 8, and 12. There we go. There's our LCD, 12. Let's rewrite the fractions. Negative 1/3 times 1, 2, 3, 4 times 4 plus negative 1/4 times 3 times 3. Now remember, whatever you do to the bottom, you also have to do to the top. Now let's multiply. That becomes negative 4/12 plus negative 3/12. All right, once again, this is why we have to remember our integer addition rules. I have an addition sign here, which means I can use integer addition rules. I have two signs that are the same, therefore I can add and keep. 4 plus 3, 7. Keep the negative sign, write that over 12. There we go, that's our final answer. It's as simplified as it can go. All right, at this point on your index card, I want you to take 1 minute to go ahead and summarize. What you've learned up to this point in your own words on your index card. And then begin watching video 2 when you are ready. See you in a bit.